morning, guys. So, what we're doing today is we are finishing up Unit 1, Lesson 8, Part 2. So, we're going to do the second half of this lesson. So, we should be on page 42. Okay, I'm just calling it Part 2 because it feels right. So, again, our learning target is I can model with linear equations, except today our focus is on some real world applications of some reasoning skills. Algebra really is all about reasoning and exercising that brain to get some of those linear thoughts going on. If this, then this, and the balance part of life. Okay, so I know sometimes we question what's going on, but we are building up those brain muscles. Okay, so what we're going to do is we're just going to jump in. I don't want to waste too much time. So here we go. There are many scenarios that can be modeled with linear equations. They can involve age, rates, and other considerations as well as the geometric ones that we studied yesterday. Exercise number 1. Shauna's age is 8 years more than 3 times Evie's age. So let's underline some of that. 8 years more than 3 times Evie's age. Let the variable E represent Evie's age. So I'm actually going to write this down. Let E equal Evie's age, just to keep my brain focused back on who I am studying and what their age is. If Evie was 7 years old, how old would Shauna be given the information in the problem? So if Evie is 7, Shauna is 8 years more than means plus 3 times Evie's age, so 3 times 7. So let's see, we have to do order of operations, so we have to do multiplication before addition. So we would have 8 plus 21, 3 times 7 is 21, and 8 plus 21 is 29. So Shauna would be 29 years old. Give an expression for Shauna's age in terms of Evie's age. So we kind of did that. We kind of wrote the expression right here. So we would have 8 more than 3 times Evie's age. So this time we're just using an E to represent that. We can also write this 3E plus 8, where we put the variable first. And this is actually called standard form. Okay, that's the more traditional way to write it. All right, let's go to C. If the sum of their ages, what does sum mean? Sum is the addition. The addition of their ages is 56 years. Set up and solve an equation to find E. So there's our action words. Set up and solve an equation. So we're looking for that equal sign now. So we have to add their two ages. So this right here, this expression, this is the expression for Shauna's age. So when we had our let E equal Evie's age, Shauna's age is this expression here. So we're going to take Shauna's age, 3E plus 8, and we're going to add it. We're going to find the sum of that and Evie's. We're going to add it to Evie's age. And it says the sum is, there's your equal sign, is 56 years old. We'll make that equal to 56. So we've set up our equation. Now we're going to solve it. Put in our balance beam. We're going to combine like terms here on the left. So 3E plus E is 4E plus 8 equals 56. So this was 1E, remember. So 3E plus 1E would add to 4E, and then the plus 8 comes down. Okay, let's move that plus 8. We're going to subtract 8 on both sides, doing the opposite operation. These cancel. We're left with 4E equals 48. Divide by our coefficient of 4, and we get E equals 12. Okay? Did we do the directions? Set up and solve an equation. We set it up and we solved it to find the value of E. We know the value of E, so we are good. Now it wants to do one more thing. We want to know how old is Shauna. So remember, this is Shauna's age right here, this expression, and we know E, so now we're going to plug it in. So 3E plus 8, 3 times 12 plus 8. Again, order of operations is important, so multiplication first. We could type this whole thing into our calculator, PS. So that means we're getting 44. So Shauna is 44 years old. Okay, I guess I'll bubble cloud E equals 12 as well. That's another answer for us. Okay, hopefully that problem wasn't too hard. I'm sure it's easier when Mrs. Brown is leading us through it. So let's try another one. Levi, sorry, going with Evie. Levi is currently 41 years old and his daughter Nora is 5. In an unknown number of years, N, Levi will be 4 times as old as Nora. Whoa, let's slow down a minute. Let's start underlining and circling some stuff. I'm going to get out my blue highlighter here. So Levi is currently 41 years old and his daughter Nora is 5. In an unknown number of years, so in N years, Levi will be 4 times, Levi will be 4 times as old as Nora. Okay. Wants to know how old will they both be in 13 years. So we would take 41 and add it to 13 to get Levi's age. We're going to get 54 years for this one, years old. And then we would take the 5 years and add it to 13 to find out that she would be 18 years old. So in 13 years, Nora will be 18 years old and Levi will be 54 years old. How many times older is Levi than Nora at this point? So to find out how many times older he is, we're going to take how old he is now, at the 13 years from now, and we're going to divide it by the 18. So we're dividing Levi by Nora. Let's see, 54 divided by 18 will give me 3. So he is 3 times older at this point. Okay, so what we need to think about when we go to set up and solve this equation to find the value of n is how we are finding all of this in the example. So in order to find these two numbers that we divided and this answer of 3, we had to take their original ages and add them to the number of years we were looking for. So what we're going to do here is we're going to say that Levi is, there's our equal, okay? Levi is, Levi will be, there's another equals right there. So Levi, 41 years old plus those n years, he will be, which means equal, he will equal 4 times as old as Nora. Nora will be 5 plus the same number of years. So that's one simple way to write it. This is going to be our easiest way to solve it. Let me turn my paper over and show you another way we could have written it. Okay? Actually, I'll just squeeze it in right here so you can see where I'm getting all the information. So if I wanted to divide Levi divided by Nora, I would do the 41 plus the n number of years over the 5 plus the n number of years. And when I divide these two, I want it to equal 4. Now, this is going to be a much harder equation for us to solve than this one. Up to this point, I haven't shown you how to solve this equation. So we're going to use this one over here on the right, okay? Just kind of wanted to show you what that would look like if you were thinking, well, how did we go about that? Let's put in the balance beam here. Looks like we're going to have to distribute on this side. This side, there's nothing to combine, so I can just bring it down. So 4 times 5 is 20. 4 times n is positive 4n. So let's move this 1n over to the 4n. So we'll subtract 1n on both sides. We're left with 41 equals 20 plus 3n. It's the only real math I had to do there. These guys just floated down. Let's move our 20. We're going to subtract 20 on both sides, shrinking up my writing. We're running out of room. We get 21 equals 3n because these 20s cancel. and we divide by 3, and we get that n equals 7. So we wanted to find the value of n, and we just did. Okay? All right, let's try one more. Laura and Kirk are comparing how much they have been running. Laura has already run 36 miles, and Kirk has run 64. I'm going to bring these out of the problem quick. So Laura, 36, Kirk has run 64. Laura begins running 21 miles per week, and Kirk runs 17 miles per week. How many additional weeks W will it take for their total distance run to be equal? So Laura starts with 36 miles and then adds 21 miles per week. So 21 times W. Kirk starts with 64 miles and adds 17 miles per week. So plus 17 times W. We want to know how many weeks it will take for their distance to be equal. Equal is equal, right? It's the same as the same. So when will their distances be the same or be equal? So we're going to set these two expressions equal to one another. Laura's equal to Kirk's. Put your balance beam in and we'll solve that. Why don't you go ahead and pause the video and solve it on your own and then restart it and watch me solve it and check your answer. Okay, we're going to subtract 17W on both sides. I'm just moving the smaller one to the larger one. You could have moved it the other way. Okay, so we should get 36 plus 4W equals 64. Moving that 36, we get 4W equals, let me check my work, 28. Dividing by my coefficient, I get W equals 7. So it will take 7 weeks for them to have the same distance. Okay. I hope that some understanding came out of it. I hope that we get to really apply this in class. And I can't wait to hand out gold stars. This is the tough stuff. Have a great night, guys.